Hi everyone, in this video we're going to go over another Leetcode question, best time to buy and sell stock. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Say you have an array for which the ith element is the price of a given stock on day I. If you were only permitted to complete at most one transaction, in example, buy one and sell one share of the stock, design an algorithm to find the maximum profit. Note that you cannot sell a stock before you buy one. Example 1, 715364, 5 is the output, buy on day 2, price 1, and sell on day 5. Price 6, profit 6 minus 1, 5, not 7 minus 1, 6. A selling price needs to be larger than buying price. So 761, in this case no transaction is done, maximum profit is 0. So let's try to understand what the question is telling us. This is a very simple question. This could be one of the simplest questions, but it's kind of difficult to understand from the question. That's the tricky part here. We need to understand what the question is telling us. So ith element is the price of the given stock on day I. On day I, the stock price is 7. On this day, stock price is 1. On this day, stock price is 5. And I can only buy and sell one stock. What I need to do is, I need to make the maximum profit. For example, if I buy this day and stock price is 7 and I sell next day, I would lose money. So I can't do this. I need to buy when stock price is low and sell when stock price is high. And I cannot go back in time. For example, I cannot do buy here and sell here. So it has to be one of these numbers. One of these days I need to sell my stock. So this one, again, I buy in one of them and sell, then I lose money, so the output is 0. I can't sell when it's less, when the price is lower. So in this case, I return 0. So how are we going to solve this question? This could be a cadence algorithm question, but we are going to use a much simpler approach to solve this. Basically, this is our array, and we are keeping a minimum and maximum number here. We will iterate through the array with a for loop, and at every index, we need to check min and max values. Min value is the lowest of the array. We will try to keep, we'll try to find the lowest number in the array with the min, and max will be the lowest number, the current number minus the current number minus the min number, compare it to the global maximum. Let's do one by one and try to understand. For example, this one, in this case, minimum is 0, maximum is 0. So minimum starts with prices of 0. So in this case, we start with minimum 7. I made a mistake here, sorry. Minimum is on the day 1. This is the minimum, current minimum we have. And we will start looping through. On this day, we will compare. Is 1 is less than 7? Yes, so our new minimum is this. And continue. Is 1 less than 5? Yes, so minimum stays, and we need to check the maximum. Our current maximum is 0. 5 minus 1 is 4. So this maximum is greater than our global maximum. So we'll set 4. Then compare with the minimum. So on each iteration we compare. So we are here, 3. Is 3 greater than minimum? Yes, so minimum stays the same. Let's check maximum. 3 minus 1 is 2, and maximum is greater, so both of them stays the same. We continue. Is 6 greater than minimum? Yes, so minimum stays the same. Let's check maximum. 6 minus min is 5. 5 is greater than our global maximum, so we set the maximum to 5. And go for the last one. Minimum is 4, so minimum is 1, stays the same. And check for the difference between current in this minus minimum, and that will give me 3. So max stays the same, min stays the same. And we will return 5 in the answer. That is the maximum number we find here. Let's see this in the algorithm, and it will make more sense if we also do it in the algorithm. So we start with prices of 0 as a min, and maximum is current maximum is 0. We are in this 0, and we start iterating in this one. Prices of I is greater than min, so 1 is greater than min. No, so we set the new min. Then our new min is 1. So we set min is prices of I. Continue. Is prices of I greater than min? Yes, that's the case. 5 is greater than 1. Then we set the new max. Max is math.max. The global maximum, compare it to prices of I minus min. So prices of I is 5, minus min is 4. We will compare 4 and our global maximum 0. So we'll pick 4 as the new maximum. So let's update the maximum here. And here, we'll compare minimum and 3. Prices of I greater than minimum. 3 is greater than 1. Yes, that's true. So let's check the max now. If prices of I is greater than minimum, we are not touching the min. Min stays the same. We are looking for the lowest minimum here. So if this is greater than min, we are not touching the min. So min stays the same. Let's find the new max. Is this max greater than our max? Let's try. So math.max, our current max is in this case 4. In this case, our current max is 4. And prices of I is 3 minus 1 is 2. So what do we pick? We keep the maximum as it is, and we are not changing anything. Max is still 4. So we continue. Prices of I is 6 is greater than minimum 1. Yes, that's the case. So min stays the same. We're not updating the min, and we are updating the max. Math@max is, let's erase this. The current maximum is 4, and prices of I is 6 minus min 1 is 5. And we will pick the maximum number here, and in this case max is 5. So what do? We update the maximum number. And the last one. Is 4 greater than min? No. Also, let's check the max. 4 minus 1 is the new difference here. Our new difference value. Excuse me. So we will compare with 3 and 5. Which is bigger? Max is bigger, so it stays the same. And finally, we return the maximum number we found. And that's the answer. Let's see it in the code. Okay, so here, let's run the code. Okay, this works. So basically, we check if linked is 0, then return 0. Set the max, set the min, go through the array, check min and max in every iteration. Set min and max. It's very logical. I mean, if it's less, then set the min. If it's greater than min, set the max. That's all we need to do. Then return max. Submit. And this works. It was a simple question, but this can lead to the Cadence algorithm question as well, so it would be interesting. So I would recommend you read this. So where they slightly tweak the question to, then it's becoming a Cadence algorithm question. So I hope you found this one helpful, and I have more videos coming up. If you subscribe to my channel, then we can meet again later. Thanks for watching. Goodbye.